Okay, here we're going to do an example problem from set theory that is testing to see whether or not you understand how to shade in Venn diagrams according to some prescription given to you here, parts A through H. I gave you some nice Venn diagrams to use here, and I'm going to fill these in for you. I'm going to connect my tablet to the battery real quick here. And then continue with this video. Bear with me. Eating through my battery here this evening. Okay. First, part A. I'm going to go A intersect B. Well, that is the place where A and B overlap with one another, so I'm going to fill this sort of football-shaped region in, and maybe just for security, I'll trace it around like that. That's A intersect B. For part B, I'm going to go A intersect B, and I'm going to take A intersect B, and I'm going to take out C. And so I'm going to take the region I had for part A, and I'm going to cut out C. Imagine taking a knife and cutting out the part from C, and what I'm going to be left with is just this region over here on the left. Okay? So it's A intersected B, gives me that football, but I'm going to cut out the circle of C, and that's what I get. For part C, I'm going to do A intersect B union B intersect C. Okay, this is a union. The overall structure of this is a union. When I take the union of two sets, like A union B, I can just shade in one of them, and then I can shade in the other. I can just shade them in one after the other, and then everything that's shaded is in the union. And I'm going to do that here. So I'm going to shade everything in the same way. A intersect B, I'm going to shade that in first. A intersect B is this football-shaped region. And B intersect C is where B and C overlap, this football-shaped region. So I'm just going to shade in everything that's in either of those two football-shaped regions. And there we have it. There's part C. That is the union of two football-shaped regions that happen to overlap, but there we have it. For part D, it says A intersects B intersects C. Now, we know through associativity that this is equal to A intersect B intersected with C, and it's also equal to A intersected with the intersection of B and C. And because of associativity, we can do these in any order. It's kind of the same way that we can write x plus y plus z, and we don't have to put parentheses around anything here because of associativity. Same thing here. We don't put the parentheses because we don't need to. Okay? And basically this is the region where A, B, and C overlap. The simple intersection of two sets is where the two of them overlap. When I have three in the intersection is where all three overlap. And all three sets are overlapping just in this central region here in this diagram. Okay? So there's the overlap of the three. If you wanted to, you could do A intersect B first, and it would be this football-shaped region here. And then you could intersect that with B. Intersect B, then you could intersect that with C. And that football-shaped region intersects with C just here, which is exactly the same region I've got. Okay? Just that middle region where all three of them overlap. Part E says we want to go A minus the union of B and C. Okay. The union of B and C is this entire, I call it a snowman-shaped region here. And I'm going to take A and I'm going to cut out that union. And so when I cut that union out from A, I'm going to have A, but I'm going to cut that snowman out of A, so to speak. And I'm going to be left with the shaded region here. Let me go ahead and do that to it. Probably makes my file size a little bit bigger. Okay, so that's part E. Part F is A minus B intersect C. Okay, let's see. A minus the intersection of B and C. Well, here's the intersection of B and C. Is this little football-shaped region? And I'm going to cut that little region out of the set A. And so I'm going to be left with everything in A except for that little football-shaped region. And so I can go all the way across here on the set A. Remember, I'm filling in all of set A, A's entire circle, except for I've cut out that football-shaped region. So there's part F. Part G looks like, but it's a union. So I can just shade in one side, and then just shade in the other, and then everything that's shaded is the union. Okay, remember the union shades both sets, and so I can just shade one in and then the other, and I'm done. Okay, so part G says A minus B intersects C. Hey, that's exactly what the previous part was. So I'm going to take the union of A minus B intersects C. Okay, I'm just going to shade in the part I had previously. That's A minus B intersects C. And I'm going to union that with C minus A intersects C. Oh, yeah. You know what I'm going to do? I'm going to go up here and I'm going to use this one to do C minus A intersects C. Okay. A intersects C is this sort of vertical football, right? And I'm going to cut that A intersects C out of C. And so I get this region here. So I'm just going to add that, and that's this part on the right for part G. And so I'm just going to shade that in also down here in part G. So I'm going to shade in everything in C except for that vertical sort of football. And you can see here that I got this crazy shape now, and this is exactly what part G is asking you for. Okay, finally part H starts to look even more crazy, but you're going to see now. First of all, it is a union, and it's a union of three things. Okay, and so I'm just going to shade each one of them in. And the first one I have is A intersect B minus C. A intersect B is this football-shaped region here, and I'm going to cut C out of it. So I'm going to be left with this little chunk over here. Now, the next one is B intersects C minus A. B intersects C is this football-shaped region. I'm going to cut A out of it, and so I'm going to get B intersects C minus A. So I've taken the football-shaped region between B and C, the overlap of B and C, and I've cut out A. So I shade just that part of it. Finally, the other one is C intersect A, which is this football-shaped region, minus B. And so again, I get just this part of the overlap between A and C without that middle piece now. And so you can see we had three things, and they were all the same, except I just permuted the A, B, and C, and that's why it's so nice and symmetrical here. Okay, hope this video helps you understand how to shade in these Venn diagrams.